So this video is going to give you a little bit of insight into a cool EPROM burner, a high voltage, it's called the HV EPROM project, high voltage EPROM burner that I found while handling a certain challenge that a customer had given me. So I troubleshot a board. It's not exactly this board. This board is used for testing, but I troubleshot their board and found that they had a bad kernel. That was the issue with their SX64. The kernels on the SX64 are this 251104-04. Okay, that's the kernel. Notice that it's 24 pins. There's 2 pins on each side, so 4 pins that are open here. But so they're 24 pin chips. Those chips are commonly known as 2364. Those are the type of chips. Those are the type of EPROMs that you would use to duplicate that. The issue was, do I hunt down an SX64 kernel or take one out of our spare inventory? Or what alternatives do I have minus hunting down an original chip? Okay, so that's what I want to go through really quickly here. First thing, one alternative. I could replace that kernel with a Commodore 64 kernel. Okay, the Commodore 64 kernel is a 901.227.02. Okay, so I could replace that SX64 kernel with the Commodore kernel. Now, the problem or the issue with that is, one, the colors would be different. And also the Commodore 64 has tape routines that the SX64 kernel does not, because the SX64 kernel doesn't have a tape port. So the memory that's typically used for the tape routines on a Commodore 64 and an SX64 is used for other things, other functions. So the Commodore 64 kernel will work, but it's going to be missing a few functions. It's not a direct replacement, but it will work if you're in a jam. So another alternative would be to replace the kernel with a JiffyDos kernel. Okay, like so. So the JiffyDos kernel, this would go on to the main board. That's the kernel. And then this other half of the JiffyDos system here is for the floppy disk drive controller. Okay, so and then you have a switch. And what does all this mean? Is the JiffyDos kernel contains the native SX64 kernel, and it also contains a JiffyDos kernel. So you could always have the switch set for the default SX64 kernel. Your problem solved, right? And then you also have the switch to allow you faster speeds for using JiffyDos instead of the native kernel. This is an option as well. It's an easy option because you've got the kernel, the native kernel already built in. You're ready to go. You just pop 2 chips out, pop 2 chips in, and find a place for the switch, and you're done. Okay, easy solution there. And since it provides a native SX64 kernel, you don't have the issues that the Commodore 64 kernel can give you. Now, another obvious solution is to burn your own kernel. Okay, a lot of folks use this type of burner here. It's very inexpensive, under $100. It's a, what is it, a TL? It's an XG Pro. This is a TL 866-2 Plus. Okay, very popular burner. The problem, though, is that the 2364s, the 24-pin chips that go in this board, require a high amount of voltage in order to burn. This works off the USB port, so it's not going to have the high voltage needed to burn the 2300 series chips, that the 24-pin chips that the board requires. So the thing that people do with this is they will burn the 28-pin chips, such as these. Okay, so these are 27 series chips. In this case, the W27C512. Okay, the 512 is a nice amount of memory to have on these ROM chips, and so you can burn these, okay, chips in there. But in order for these to work on that board, you're going to need an adapter, because the pins on this don't match up with the 24 pin needed on the Commodore or on the SX64 board. So you have an adapter. Okay, so now you can replace the kernel, the SX64 kernel with this adapter and burn these 28-pin chips, okay? And you plug it on this adapter. The cool thing about these adapters is that these specific chips, because you can get them in different sizes, memory sizes, of course, but the 512 here allows me to have, 4 or so kernels. So using jumper settings, I can actually choose which kernel on that chip is active. So I can have the native kernel, I can have the JiffyDos kernel, I can have the Dolphin kernel, so I can have a number of kernels. Okay, but the issue with that is that that doesn't look like the default kernel chip does, obviously. And then let me also point out, any 27 series chip will work great with it. And it also has a lot of other functionality beyond just burning EPROMs. This TL866 will also test RAM. It'll also test your 7400 series chips. So it has a lot of other uses, not just burning EPROMs. So it's a cool device to have, and it's, like I said, it's very inexpensive. But unfortunately, it can't provide the higher voltage it needs for the 2364 chips that the entails, and that voltage is around 26 volts. I think the most voltage this provides is about 18. So there's that. The other thing is, if this is a side note, that if you're trying to do this adapter, this adapter works great for the Commodore 64, but just keep in mind that they may not work for earlier Commodore systems like the PETs, because back then MOS built different versions of the 2364 on top of everything else. So the adapters here are good for the 2364s that you're adapting to a Commodore 64 system, which uses what's called the negative active logic, but they may not work correctly with the older PET systems. And it also depends on which version of a 2364 you have. So that's just a little side note. So that being said, what other options do we have? Okay, we went the JiffyDos option, we went the Commodore 64 kernel option, the TL866 burner option. The other option is to burn a native chip. So you can spend hundreds, if not thousands of dollars on the EPROM burner that'll spit out the 26 volts that you need in order to burn 2364 chips. But here's another option. I can use this Commodore 64 EPROM burner. This will put out the voltage necessary to burn, I don't want to say 2364 chips, they're really hard to find, but you can find something very similar, which are these guys here. Okay, so what those are is the MCM68766 chip. Okay, they're UV programmable ROMs. Okay, so those are relatively easy to find. At least I found them very easy to find. So the MCM68766 and the MCM68764 chips is what I use to substitute for the 2364 chips, which are 24 pins. These are 24 pins, okay? So if we do that, then we'll have a relatively pretty close to original SX64 24-pin chip, and it'll certainly have the SX64 kernel on it. Not very many people have a Promenade, not easy to find, and on top of that, it's a little bit kludgy. So there's that. Not that it's not good, I'm just saying that it has its challenges. But then, in doing a little bit of research of trying to find an inexpensive EPROM burner that'll go as high as 26 volts to burn these types of chips, the 24 pins. And let me state the reason for this is the customer in this case wanted a chip that was, if not original, true to the original 24 pins. They didn't want to see JiffyDos circuit. They didn't a kernel. They didn't want to see an adapter board. They wanted something that was close to time period correct. So that's why we're going through this exercise. And that's why I'm figuring, well, I can just burn them on here. It's not a problem. But I thought to myself, I'm going to make this video, and not everybody has one of these. And so I did a little bit of research on how much some of these devices that have the high voltage cost. And I stumbled this project called HV EPROM project, which is HV, I'm assuming, is for high voltage. So the HV EPROM project is an interesting project. You have to source the parts, you have to source the board. I'll put the link in the description. You can go to PCBWay, I guess. This is the board. I already built it. You have to source all the parts, but I'll leave it in the link in the description that takes you to this project. Also has a bill of materials that works with Mauser. So the parts are very easy to order. This costs less than like 35 bucks. The board, if you get it on PCBWay or wherever else, they provide the Gerber files. You can probably get them for like $10. So for $50 or so, you can build this EPROM program, but it doesn't stop there. It's a little bit more than $50. You have to add another 20, and I'll explain why. This burner, notice, hey, where does it plug in? Where's the voltage come from? Well, that works with an Arduino board. This attaches to this Mega 2560 R3 shield. So you can see the pins on the bottom here will line up with the Arduino shield here, and you just plug it in to those, and the shield provides the voltage. So here's the USB port that goes to the computer for the software that's going to do the burning, and here's the power plug that'll bring in the voltage. And the voltage that you need to feed this in order to burn these high voltage chips is roughly a little over 13 volts, maybe 13.1 volts. So if you have a power supply capable of 13.1 volts or so, I have a variable power supply. You plug that in here, set it to 13.1 volts, and then you're off to the races. Okay, you plug your USB port into the computer, and now all of a sudden you're burning MCM68 766 chips like these, which take the place of 2364 chips, if that makes sense. So that is the history of this little project, per se, what got me here. So what I'm going to do with this remaining time on this video is we're going to go ahead, plug this in, and load up the software, and we're going to burn an SX-64 kernel off of one of the MCM 687-66 chips here. All right, so stay tuned. Let's see how this goes. So this programmer here can burn 2704, 2708, the TMS 2716, an MCM 68764, and an MCM 68766 EPROM. It's built primarily for those chips and those chips alone, but the MCM 68764 and MCM 68766 chips are pretty common to replace the 2364s. So it's actually a good burner for me to have, which I can use the Promenade, but this is a good alternative for me as well. All right, so let's get down to it. All right, so here we go. Got this thing put together, so let's give it a test before we burn our first chip. We don't want to burn out, our chip by accident if we don't have to. So first thing we're going to do is set our power supply here, and turn this guy on and set it to about 13 volts. Okay, you can go up a little higher. It's not really going to ruin anything. The 2708 chips are the ones that are really finicky with the power supply and really should be around 13 volts. But for what we're going to do with the MCM chips, not the high voltage like that doesn't really mean much. 12 volts should be fine actually. But anyways, nonetheless, that's what we're going to set it at. All right, so we'll plug this guy in. And you should see some lights come on, which they do. And then we're going to have the USB port hooked up to our computer. Okay, we got that going. So let's get to the computer here and see what we need to do on that side. Okay. Okay, on the computer side, the first thing we want to do is we want to download the Arduino software for our Mega card here. So you go to arduino.cc and software. I wouldn't download the Arduino IDE 221. It doesn't contain the hardware folder, the driver that's needed. I would just come down a little bit here and I would download the Arduino IDE 1.8.19, and I'm going to choose Windows Win 7 and newer. And the reason for that is when you install this, it'll also install the USB drivers that you need for this card. If you downloaded this one, you would need to go out and get the driver from for that card from the internet. So this provides everything you need. So that's what we do first. Okay, so click that and download. Okay, once we have that downloaded, you just go ahead and double click on it and perform the install. So we already have 1.819 already installed, so I don't want to uninstall it and do all that stuff, but nonetheless, just go through the process. Make sure that there's a little box that's there that says install USB drivers. Make sure that box is checked. You want to install the drivers on this. Okay. Once this is installed and you plug in your, you might have to unplug and replug in your Mega card here. Once that's done, then you left click on the Windows icon on the bottom left of your Windows machine and you click on Device Manager, and then you'll come up with this. So in Device Manager here, what you're going to find is on your ports, you're going to see something that says Silicon Labs CP210X. So that is the driver for your card. So that needs to be enabled, no errors. Once you right click on that and you go to Properties, you want to set the port settings to 115.200. That's what we're going to use for updating the firmware on the new shield that we're putting in. Okay, so you set that up like so and click OK. Minimize this, don't close it. You're going to need to reopen this back up. And if you install the Arduino software correctly and the driver's working, then the next thing we want to do is we want to upload the firmware for the HV EPROM program. Okay, so in order to get the firmware, the hex file for the firmware that you need to upload to the Mega card, you need to go, first of all, go to the project site. You should bookmark this. So here's the project site. mattmillan.com projects HV EPROM -project. You go to the site, gives you some more information on the shield here that we've built, and you can click here to get more information on that specific project. But if you keep coming down here, you're going to see this programmer firmware source, and you're going to also see the Windows GUI binary download. So in order to get the hex file you need, you click on the programmer firmware source, and the hex file that you need is right here, HV EPROM hex. Now, don't right click and save the link, because that's not going to save the hex file as it should be. So you want to click on this, and once you click on this, then you come up here to the right and you click download raw file, okay? And then you dump that file. Okay, so that'll give you the firmware that you need. The other thing you're going to need, obviously, is the GUI. So you come here to the Windows GUI binary download, and this will download the HV EPROM zip file that has the GUI in it. Okay, now I've already done that, so let me show you how that works. So what's inside the HV EPROM GUI zip file are these: HV EPROM common, the program, the configuration for the program. You don't need to touch any of these. This bin file that I have in there is the SX-64 kernel that we're going to burn later. So you don't have to touch these, just unzip these into a folder. I called my folder HV EPROM. What's not in here is that hex file that we downloaded, so we got to copy that over. Okay, so now we have all the files that we need in here. So now we have to load the firmware onto the card. So how do we do that? We're going to go, first of all, to our C drive. And in Programs File 86, there's a folder called Arduino. We click on that, and then there's a folder called Hardware. And under Hardware, there's a folder called Tools, and then AVR, and then Bin. Okay, so keep a note of that. Why is that important? Because here, I'm going to open up a command window. And in this command window, I'm already in this folder. I'm going to type in this AVR dude, so that's a program that's inside this folder. So there's AVR dude, and then this is a -C. It shows where the configuration file is. So in quotes, I put the entire folder where that configuration file resides. Okay, and it's in the ETC folder. So I'm right here right now in the AVR bin folder, but I'm going to be pointing to the AVR ETC folder, and there's my AVR dude configuration file. That's necessary. Then -V means verify the firmware update, and then this is the board. -P, we're using an ATmega 2560. This is the communication type. This is the COM port. I'm on COM 4, as you saw here. If you look at the properties, it shows COM 4 right here. Okay. The baud rate, we want to set the baud rate to 115,200. Okay. And then we're going to update. And then I have the HV EPROM already in this folder. I copied it into the folder. You can see it right here, just so I don't have to type in a full path to wherever I put the folder. Otherwise, you're going to have to type a full path here. So in other words, if your folder is in a directory called temp, you're going to have to do something like that. Okay. So let's go ahead and see what happens here. When I run this, okay, so you can see it's updating the firmware. It found the device. So if you had an issue with the COM port or the device or whatever, you'll get an error right up here. So you can see that it found the HV EPROM. If you put the file path for the HV EPROM wrong, it'll tell you, it'll error out. If you put the path wrong for the AVR dude configuration file, it'll tell you, and it won't run this, it'll time out. So this tells you that everything is done, everything was read, everything was updated. So we are good as far as the firmware goes on the card. We can close this window, we don't need it anymore. And then we can also close out of here and go back to our HV EPROM folder where we dumped all the files into. All right, so now what I'm going to do is the HV EPROM, for some reason, doesn't like the 115200 baud rate. And if we look at the config for it, it defaults to 38400. I've tried changes to 115200 and it didn't find the card. So I'm left this back to the default baud rate of 38400. So doing that means we need to go back to our device manager and go back to the properties here, go back to port settings and change this baud rate back to 38400. Okay, and then we don't need this anymore because we should be all set. Now at this point, you probably need to unplug the USB port and plug it back in again, just in case. So we'll do that. So at this point, we should be able to run the main program here in order to read and write our chips. Okay, so you get this. So serial port, COM4, that's where our mega board is at. So that's, correct. As far as the device, the board is set right now for this mode. There's a switch on the board to let you change the modes for the device. This is the chip that we want to burn, but you can see there's all of these are the chip types that you can actually either read or write, or both. Okay, so we're going to be writing and burning an MCM 68766. You also have a configuration. I don't really need to change the defaults. The number of passes is fine. So all of these things, write and verify, the defaults are fine. So before we do anything though, before we load a chip or anything like that, you don't want to burn a good chip. What we want to do is test the hardware and test the board first to make sure we can communicate with it for one. So we can go here to Tools and a hardware test. And I have this board, the switch on this board set. I built this board to be to allow all the chips possible that it can handle. But you can also build a board. If you go to the project page, you can see that you can only build it so it's dedicated to one type of chip. But I built it to enable any type of chip that it can handle. So that's what the mode I have here is. Okay, so once I have this, these instructions is what you follow after you hit the start test. Okay, now one way to test if you have anything that says it can't find it can't communicate with the board, one thing you can do is unplug the board that you just built, so only the mega board, the Arduino board, is plugged in. And then if you hit start test with just the Arduino board plugged in, it'll tell you that it can't find the shield. And so that's how you know that you're communicating fine with the Arduino board. So that way, if you have an error, you'll know that it's not on the board you just built. If you have a communication error though, without the board you just built being plugged into the Arduino, then you know that you have a communication problem. It's nothing that you've built. It's the Arduino, whether it's a bad board or whether it's a counterfeit board that's not really acting like a 2560, or whatever the case may be. Your problem is with your Arduino installation and with the Arduino board, not with the project board. Okay, so here let's go ahead and start this test. And it's a good thing that we didn't get any errors. It would have errored if it would have been an issue, but in the end the button went to end test. So while this test is going on, what it's telling you to do now is look at the pins on the IC socket and test the voltages here. So let's go ahead and do that now. Okay, so what it's telling you now is that you should see 5 volts on pin 24 of the IC socket, which is good. And then in pin 20, we should be seeing around 4.5 volts. Okay, so that's 24, 23, 22, 21, pin 20. There you go. 4.8 volts, and that's fine. That's where we need to be. All right, so this test is done. So we can end this test and go on to the next test. And so the next test, you start the test and you should see 0 volts on pin 20. So 24, 23, 22, 21, 20. And so basically 0 volts, 56 millivolts is around 0 volts. So we can end this test. And then the next test here, start this test, and we should see 25 volts now on pin 20. Okay, 24, 23, 22, 21, 20. And sure enough, we see 25 volts. Okay, so I'm not going to go through all the tests. There's 3 more tests. If you go to the next test and start it, you can see that it tells you, hey, check these pins, and you should see this voltage. I'm pretty comfortable at this point that this is working as it should. So I think we are ready to actually put a chip on here and see what we've got. So I have an MCM 68766 chip here. So the first thing we want to do is make sure that we can communicate and that the chip is blank, so we'll do a blank check. And there you go. It means it's communicated with the chip. It found that the chip is blank, which it should. It's a brand new chip. And there you have it. So now let's go ahead and open up the bin file that we want, the binary file that we want to burn onto this chip. And that's the kernel SX64, the SX64 kernel. Okay, so we want to make sure that the chip is blank. We want to write, and then we want to verify it. Okay, so let's start this operation. So there we go. Write was complete. So this is really good. So let's read from the device. Let's read the chip. Okay, 8V192. The one knock that I do have with this board, or with the software itself, is that I wish it would give you the CRC number. But I'm pretty confident that this chip is good. It went through the verify. I could read it and all that. But there is another way for us to test it, and that is to put it into the back bit tester. Okay, I'm going to choose 2364. That's the chip we're mimicking. Here's a chip we just burnt. Pop that in there. Okay, hit test. And there we go, 24104 kernel. And that's the correct checksum. Okay, so we just burnt our SX64 kernel onto what looks like an old school chip, 24 pins. And it was really that easy. This is also great for IBM 24-pin chips of the same 23 series as well. So it's actually a really nifty device to have for, like I said, under the $80 it costs to build it and everything. Now, if you want to reuse this chip for something else, or didn't burn correctly, what have you, and you want to totally erase it, you can. You just have to use, it's not an EEPROM, so you have to erase it under UV light. But for like 25 bucks, you pick up one of these guys on eBay. And it has a little drawer where you can put, about half a dozen chips in there. Facing up, obviously. Here's the timer. About 30 minutes is all you really need. You turn it on. 30 minutes later, when the timer goes off, your chips should be erased. If they're not, you just leave them in there for a little bit longer. So, pretty easy setup. All right. So, go back here. We can close this program now. And we are done. That is really basically it. So let's summarize everything we've done here and do a little quick sign off. And yeah, stay tuned. All right, before we wrap this up, I just wanted to give a little shout out, and let's take a look at Matt Millman's page where he created this project. I think it's totally cool that someone had a need, fulfilled that need, and then shared the project with the community. The link is in the description, but he has a lot of projects. This is the shield that we built, okay? But he has other shields as well, which are more dedicated. So this is really cool. I built the all-in-one, the one that handles the most chips, and that's why there's a switch on the board, and it allows you to select the chip types and everything. Here's the software. Here are the links to the firmware that I showed you earlier, and links to the GUI, some of the release notes, and the history. The GitHub pages on there. Some troubleshooting. So a lot of good stuff on here. A lot of good notes and remarks from the user community as well, issues they may have or suggestions that they have as well. These are all of the projects themselves, but if you click on the actual project, it gives you more detail. Here's what the board should look like when you're done. I don't use an RS-232 interface. You could, but I don't, so it saved me some parts and some build time. Here's a little bit of background on it, the voltage stuff, the design, a lot of good stuff. Even if you don't plan on building it, this is a great site to go to and just gain a little bit of knowledge. Again, just a fun project to build. So there you have it. Can't say enough raving fan for sure. So, like I always say, I think this will be a wrap. Live for today. You only live once. Life is short, man. Enjoy the heck out of it. All right. Peace out.